Hello everyone, it's July the 16th. Look at this. Look at this. I thought it was going to be easy going today, but it's not going to be an easy one. Alright, let's take a look. K inverse pairs array. For an integer array nums, an inverse pair is a pair of integers where 0ij, and nums I is larger than nums j, so the value in front is bigger than the value behind. Given two integers n and k, return the number of different arrays consist of numbers from 1 to n, such that there are exactly k inverse pairs. So 1 to n, okay, and we have k inverse, have 0 inverse pairs. If I have 1, then that's one pair, that's another pair, have exactly one inverse pair, okay? I think I understand what the problem is looking for. So, given 1 to n, I want to find out, okay, if I have a 0 inverse pair is always going to be how it's original. If I have 1 inverse pair, I seem to remember this. If I have 1 inverse pair, that means 1 inverse pair, so I have 1 so everybody else has to be exactly the same, and I have 1 pair that's inversed, right? And I cannot inverse at the beginning. Let's say I have like 1, 2, 3, 4, 5, right? If I inverse at the beginning, I can inverse at the beginning. I can inverse at the beginning, and then the rest keep the same. So the one in front, I need to be larger than one of the values in the back, and I can do that. So can I put anything at the beginning, like 3, 1, 2, 4, 5? I can't, because 3 is larger than 1 and 3 is larger than 2. So I cannot put 3. So the only thing I can put front is 2 if I want 1 inverse, because I can only be larger than one of the value from the behind. So yeah, because everything else has to maintain, so I just take 1 out and put it somewhere else. So 2 take out, put it here. So if I want to take 3 out, I have 1, 2, 4, 5. If I have to take 3 out, I need to put in between 1 and 2, right? So 1, 3, 2, 4, 5. Then 3 is larger than 2, and that's the only thing 3 is larger than, because everything else is fine, and then 1 is smaller than 3, so that's also fine. So 3 is larger than 1, so that's fine. And then we're going to take 4 out, so 1, 2, 3, 5. So 1, 2, 4, 3, 5. 4 is larger than 3, right? And then we're going to take 5 out. 1, 2, 3. Ooh, take 5 out. 5, 4. Yes, 5, 4. 1, 2, 3, 5, 4. And that's it. That's 1. So basically just take everything and put it in front of value that's right smaller than you, because if you do 2 times, then you will be larger than 2 of them, right? So that's 1. So we can try. Basically, I say if I give them 5, so 1, 2, 3, 4, 5, I want to have 1, so it's going to be 1, 2, it's going to be 4. Right? I have 4 different ways. Yes, 4 different ways. How about 2? Exactly 2 inverse pairs. So if 2, so what you need is some values larger than 2 values, right? So 1 and 2 cannot do, because for 1, nothing is smaller than 1. For 2, only one number is smaller than 2. So we have to start with 3. So we'll move 3 forward. So we have 3, 1, 2, 4, 5. And 3 larger than 1, larger than 2, and everything's fine. So we can do 1, 4, 2, 3, 5. Right? 4 move up 2 times. And we can do 1, 2, 5, 3, 4. So that's 3, right? And if you put anywhere else, it's not going to work. But hold on a second with this. Hold on a second, because that's moving one value. Now it is, so I say I can have 3, I can have one value. So previous is 1, so you can have only one value larger than the other value. And if I go too far, yeah. And everything else has to be sorted. So this value needs to put somewhere that can only larger than one value. Now everybody else sorted, then we need to rearrange the array. What I can do is one value larger than 2, or 2 values, they're both larger than 1, right? So 2 values larger than 1. So if it's 2 values larger than 1, what can we do? We can say, okay, we can say both of them larger than 1. Then that's 2 and 3. So we can do 2, 3, 1, 4, 5, right? We have 2 values, 2 and 3. They both larger than 1. And then that will work. And then everybody else will stay the same. So in this case, 2 values larger than 1. And then I can say 2 values larger than 2. So that's 3 and 4, right? 3 and 4. And then I cannot say, let's say 3 and 4 larger than 1, because 3 and 4, if we want them larger than 1, and then they are the only one larger than 1, that means 2 has to go in front of them. But if 2 go in front of them, 2 will be also larger than 1. So that's not possible. So it has to be adjacent. So now we're going to say 3 and 4, and they have to be larger than 2. So it'll be 1, 3, 4, 2, 5. Right? 3, 4 larger than 2. And 4, 5 need to be larger than 3. So it'll be 1, 2, 4, 5, 3. And larger than 4, we only have 1, so that's it. So I have 6, which means if we go 5 and then 2, we shall have 6. Is that right? Ooh, that was not right. It's supposed to be 9. There's one more situation I didn't consider. What other condition I didn't consider? 2, 1, 3, 5, 4. So we have 2 but separate. So basically we say, we go back to the original, we have 2, 1, 3, 4, 5. That's have 1. So I say, okay, how about 3, 4, 5? It gave me 1. Well, 3, 4, 5 gave me 1. We can have 4, 3, 5. We have 3, 5, 4. So now we have 2. Interesting. And then we have 1, 3, 2, 4, 5, right? And then I say, okay, 4, 5 give me 1. So I can say 1, 3, 2, 5, 4, right? And that's good because the only reverse is 2. But 1, 2, 4, 3, 5, it doesn't work because 4, 3 is already there. So that's 9. Yeah, I got all 9. So what is the pattern? Can I build new ones from the previous ones? I mean, I have 1, right? 1,000. Yeah, I still haven't I didn't see the pattern yet. Right, okay, so I have this pattern. I need to produce 1 more. So I don't want to keep this. And how do I produce more? So I say, okay, 3 is larger than 2. So we have that one. So 2 can be 3 larger than 1. So I put them in. Okay. What else? I can say, well, 4 larger than 2. So now I can produce another one. Okay. I don't like it. Hold on. We can have 1 larger than 2. So we can have 3, 1, 2, 4, 5, 4, 2, 3, 5, 5, 3, 4. Right? So we have that. Or I can have 1 and 1. 1 plus 1. So we have 2, 1, 4, 3, 5, 2, 1, 3, 5, 4. Right? So that's the 2, 1. Or we have 3, 2, 5, 4. Right? Have 2. Okay. What am I missing? I'm missing, so it's 1 larger than 2. 1 is bigger than 1, 2 plus. And we can say 1 larger than 1, 1 larger than 1. Or we can say 1 plus 1 larger than, so 2 both are larger than 1. So if we're both larger than 1, then we can move, so 2, 1 larger than both. Or we can have 1 larger than 1, 1 larger than 1 combined, yes. Or we can have both larger than 1. So I can say 3 larger than 1. So we move the smaller one, right? So we move the smaller one. So we can move the smaller one here and here and here. We can move 3 times. Right? So we have 1, 3, 4, 2, 5. And a 1, 2, 4, 5, 3. How about 3? Well, in the old way, we move the bigger one. So we can move the big one, move the smaller one. So move the big one. Say move 4. So 4, 1, 2, 3, 5. Or 5. Alright, so move this and move this. Okay, move 2. Or we can say 1 plus 2. Wow, that's... How are we going to do that? It's not systematic. We're going to find 2. How do we find 2? Um, 5, 3, 4. That's 1. Yeah, it's the only one. what I can say to find 2, and this one, and then we cannot find 1. So 2 is only, this is the only way. Okay. So now let's say, how about 3, 1, 2, 4, 5. Now we already have, so we just need to find 1, right? So okay, this one will have 5, 4. And then we go 4 front. So 4, 1, 2, 3, 5. This one's already done. Alright, so we have 3. So that's putting the value to the front. Cannot put 5 to the front. Okay, so now we can remove 1. So we now have 2, 3, 4, 5. We want to find 3. We can go 3, 2, 5, 1, 2. It's impossible. We can put 4 in the front. And 2, that's impossible. We can put 5 in the front. So it becomes 1, 5, 2, 3, 4. Alright? Okay, so now we have 3, 4, 5. 3, 4, 5, we cannot produce 3. So we have 1, 2, 3, 4. Are you telling me that 5 and 3 is 4? You gotta be kidding me. No, was not right. Didn't do it right. It's supposed to be 15. I only found 4. How? Okay. Yeah, I'm still trying to find the pattern. 5 and 3 is 15. What? What am I missing? Because I'm only putting 1 in front. That's why it's not working. That's putting 1 in front. So I can put 2 in front of 1, 3 in front of 1, 4 in front of 1, 5 in front of 1. Now, 1 in front of 1 is done. Now we can have 2 in front of 1. Yeah, that's the one we didn't consider. Or we can say, right, we can produce 2 in the remaining, right? Or we can put 3 in the front. And we'll produce 1 in the remaining. Ah. Okay, I'm gonna change strategy. I feel like the result of the subsequent need to be built upon the previous one. I'm trying to rebuild a one inverse. One inverse is very straightforward. Because it's a lot of restriction. That's a one inverse. We have 4, right? One inverse is straightforward. So from one inverse, how do we build two inverse? We have to build on one inverse, right? So that's one inverse. So two inverse, in my opinion, if we have a one inverse, we can start building on top of it. So we say, okay, this one have one inverse, and we want to just produce another inverse, right? How do we keep producing inverse? But then H1 you have to, oh man. Two inverse. Have to be two inverse. So if I am bigger, right? So if K inverse, if I have one value that's bigger than, if I already put this value in place such that there are K values behind after it, which is smaller than that, then those K values doesn't really matter. They can organize however they want. Right? That's correct. So as long as I define the value that is larger than the rest, so the rest can just permutation. We don't care. Okay, that is an insight. So it basically just means if you want 2, and I can say, okay, 3 is larger than 1 and 2. So I can do 1 and 2, however, they can do 1, 2, they can do 2, 1. They both, actually they don't both work. Just realized. They don't both work. They only 3, 1, 2 works. Because if we do 3, 2, 1, then we have 3 is larger than 2, 2 also larger than 1. So that doesn't work. Oh, yeah, that doesn't work. So then it has to be sorted. Yeah, I've just, whatever solution I'm thinking right now, just they don't have, what should I call it? They don't have system pattern. I want a systematic pattern. I don't feel, I was trying to see how I can use the previous result, but it's difficult to use the previous result. Because they can jump around. I think I need to think about it differently. If I say, when you have two pairs, okay, I can say, okay, I want the two pairs to be what and what. I say I want to be 3 and 1 and 3 and 2, okay? Can we like produce all these pairs and then decide how it's going to be? How difficult it is to produce these pairs. And the rest just, if I produce these pairs, and the rest must be sorted. But once you get more complicated, this can get very complicated. If we go like 50 pairs, right? How can you analyze 50 pairs? Maybe we can. 3 is larger than 1, and 3 is larger than 2. That's my 2 pair. Okay. I can say 1 value larger than 2, so it has to be 3, 1, 2. There's only one way to do it. And then once we settle down this, and the rest is straightforward because I have 2, so the rest must, in such a way, they must be larger than 3. They cannot be in front, they have to be after, and they have to be sorted. So there's only one way to do this. Okay, that's 3 and a 1 and 2, right? Say 1 value larger than like 3. Yeah, larger than 2 values. And I can say 4. 4 has 1, 2, 3, right? So I can choose 4, 1, 2, 4, 1, 3, or 4, 2, 3. So I can choose. And then the rest must be sorted. Yeah, the smaller value has to go to the front. Because that's the only, everything after this must be bigger. So everything has to be smaller, goes into the front. But in this case, like 4, 1, 2, so like the values larger than 4 must be at the back. So 5 must be at the back. Alright, and the values smaller than 1, 2 must be at the front. Smaller than 1 must be at the front. Both 1, 2 must be at the front. And I only have 3, so it's larger. If it's anything, I cannot do 4, 1, 2, 3, 5 because 3 is smaller than 4, right? So if we find a pattern, right, then we want to insert the other numbers into it. If that is the pattern, but I want, this is the only time that this is larger than. So I want everything after to be bigger than the biggest, and everything smaller than this to be in the front. But then we have trouble because 3 is in between. So this is 4, 1, 2. This is not going to happen. This is not right. And 4, 1, 3 doesn't work either because the thing's bigger than 4. So like after this has to be bigger than 4. And in the front must be smaller than 1. And I have a 2. So that doesn't work. So this one doesn't work either. So only 4, 2, 3 works. Right? We say 4, 2, 3. We have anything. So the value, if it's smaller than 2, goes front. So 1 smaller than 2 goes front. And a 5 larger can go to the end. So this one works. Yeah. And then we go to 5. 5 we have 1, 2, 3, 4. Okay, we can choose from, right? And you can say 5, 1, 2, 5, 1, 3, 5, 1, 4. But again, no matter how we choose, everything larger than 5 has to go to the end. But nothing larger than 5. So none of these work. Because you cannot put 4 at the back. Yeah, so none of these work. So if it's 5, we only have 5, 3, 4. That's the only possibility. Because anything else can do. But that's one way of doing this, right? So we have 1, 2, 5, 4, 5, 3, 4. Yeah, that's a lot of analysis. That's 1 larger than 2, we can get 2 larger than 1. But then when you get complicated, man, I have no idea. I think I solved this myself last time, but man, I have no clue. It still feels like it should be DP, right? Like if we want to find the number of arrays with exactly k inverse pairs, can we get some help from k minus 1 if we know k minus 1 inverse pairs? Okay, let's say we know the total number with k minus 1 inverse pairs. But we need to analyze for each one of them. But the value is so huge, it's impossible to analyze. Right? Oh. No. Yeah, I feel like that's not working. We have to build it. But if you build it, there are too many possibilities. Oh. Hmm. I have no idea. I need to see any hints. Tell me DP. Submission in the past. It is DP, huh? But how? I don't see the pattern. That's the thing. I don't see the pattern. Like how knowing, let's say, so we can say 5 with 1 equals 4, right? 5, 2 is equal to 9. It's like, how does that happen? And 5, 3 is equal to 15. How does that happen? Like how 5, 2 can use, let me list it out. 3, 1. What's 2, 1? What's 1? 1 is going to be 0, no matter what. So 1, 1, 0, because k can be 0. 1, 0 should be 1, right? One cannot be 1 because there's no pair. Everything 0 is 1 because we have 0 pairs, so it's only have to be sorted. How about 2, 1? 1 because it's only 2, 1, right? 2, 2, we don't have 2 pairs. 3. I want 1 pair. Okay. If I want 1 pair, that means a 0 pair. So 3, 0 is also 0. Oh, also 1. And if I say if I want 1 pair, that's okay. If I want 1 pair, I can say if I keep 1 in this position, then I have 2, 3. That's 2. And 2 need to produce 1 pair. We have 1, 3, 2. That's 1, right? Because 2, 3 it's equal to 2 produce 1 pair. Okay, now I say, because at the end, this 1 can be at any location. So I said, okay, we have 1 put in the middle location. And I have 2, 3 on either side. And then we calculate how many different already we have here. Well, we already have 1 pair here. So it's already 1 pair. Okay. And can we like change 2 and 3? Change on those sides to produce, because I already have, right? And we don't have anything else. How about put 1 at the end? then we have 2 pairs, so it's not 1. So 3 divided by 1 equal to 2. Now how about 3, 2? So for 1 in the first position, I want 2, 3, 2 to produce 2. 2 cannot produce 2, so this is not going to work. And now if 1 is in the middle, I want to produce 2. And we already have 1, right? And the goal is not changing the front. So like not moving things further to the front. I want 1 to be at this position. And for the remaining, can I produce 1? 3 produce 1, so 1 produce 1 is not possible. So that's only going to be 1. It's not possible. Now 1 is at the end. So I have 2, 3 at the front. So I want 2, 3. So when I'm at this position, we already have 2. So I want 2, 3 to produce. So 2 produces 0. We only have 1. Right? So 1 times 1, that's 1. So 3, 2 is equal to 1. Okay? How about 3, 3? 3, 3. So I want 1 in the first position. 2, 3. So 2, we need to produce 3. That's not possible. Right? So I have 2, 1. I have 3, I want to produce 2. That's not possible. So now we had 2, 3, 1, right? And 2, 3, 1, we have 2 already. Okay, we have 2 already. So I say, can 3, 2, so that's 2 already, so we should just record. And I want 2, 3 to produce 1. So 2 produce 1, we have 1 way. So we have 1 way to produce. So it's the same. So 3, 3 is also equal to 1. Let's see this. Have 1, 0, 2, 0, 2, 1, 3, 0, 3, 1, 3, 2, 3, 3. One, 1, 1, 1, 4 ones. 1, 1, 1, 1, 2. 2, 1. 1, 1, 1, 2. 1, 1, 1, 1, 2. 2, 1. So this one's supposed to be 2. So I have 3, and then on 2 pairs. Okay, I have 3 on 2 pairs. So on 2, 3 produce 2 pairs. That's not possible. This is already produced. So I want 3 to produce 1 pair. That's not possible. Now 2, 3, 1. I want, so this is already producing 2 pair. That's 1. And that's it. What else can I do? What? 3, 2 is 2. 312. How does that come to pass? Then we need to change. Like whatever do in the front, whatever those do at the end. And then we have the swap. Man, that's we make sure everything to the left is going to be smaller than everything on the right. Oh man. It doesn't work. If we swap, right? Because everything on the right is bigger than everything on the left. If we swap any value, we are going to +2. Whatever we already have, no, +1. Okay, swap can +1. So that's what it's 2. Swap can produce 1. Okay. I need to walk around. Man, this is tough. 4. The largest is like 10, right? Or 1. 1 pair. Which is 2, 3, 4 produce 1 pair. So we have 2. We already have 1 pair. And then if we swap, we'll produce 2 pairs. Yeah, if we swap, we will add 1. So we don't want to swap. This is when we have 2 pairs already, so it's not possible. And I swap. Yeah, swap always +1. So 4 1s are going to be 3. How about 4 2? 3, I want to get 2, have 2. And 2 1 3 4. That is 1. Now we can say, okay, 3 4, I want to produce 1 more. 3 4, so that's 2, produce 1, that's 1. So we have 1, right? And then we can swap. Every time we swap, we get 2. So we can swap this, so I have another 2 by swapping. And after swap, I just need to produce, because after the swap, I'll have 2 naturally, and the remainder just need to be 0, which can always be, we just sort it, that's going to be 0. Right, so that's that. Now I say I have 2 3 1 4. Naturally, that's 1, and there's nothing we can do. And so that gives us 1 2 3 4 5 6. Let's see if that's right. 4 0 4 1 4 4 2. If it's not right, I think I'm gonna just see the result. It's 1 3. That's 6 5. What? I guess one of them must be one of them must be a repeat. Holy guacamole. How is that possible? How is that possible? 2 3 4. To make 2, we have 2 different situations. Right? Because that's 3 make 2, that's 2. And then 2 1 3 4. 2 1 3 4. I can have 3 4 make 1. So I can have 2 1 4 3. Right? That's 1. Or I can swap. That's 2. And I can have 2 3 1 4. You gotta be kidding me, right? Oh, 4 1 2 3 is not right. So I swap 1, because this is larger than this, and this is also larger, so I add 1. But if I swap this, then I guess this one larger than everybody else. So I can only swap. I see. I can only swap because everything on the left is smaller than everything on the right. So if I swap this, I do add 1. But if I go too big, and also it depends on where you swap, right? Because the assumption is everything on the left is sorted. And go 1, and then everything's sorted on the right. So once we swap a value to the left, and this is big, so we have basically this one is going to be larger than this much, right? So the more to the front, we get more. This one's larger than all that. And then if it's 4, I cannot swap. Because I only have 2 on the left, right? I only have 2 on the left. If I swap 4, then we have 3 on the left. Yeah, whenever I swap, this has to be only larger than 2 on the left. This has to be larger than 2 on the left. How is that possible then? It will be larger than more. So anyway, 4, 1, 2, 3 doesn't work. And the last one is 2, 3, 1, 4. That's automatic. So 1, 2, 3, 4, 5. That's 5. Yes, that's only 1. So that means it's 5. How about for 3? 3 need to make 3. I never done 3 made a 3. We can. 3 make 3. I did. 3 make 3 is 1. So 4, 3, 2, right? Yeah. So that's 1. And 2, 1, 3, 4. We need to make 3. We need to say 3, 4. So 2 need to make 2. That's not possible. The most they can make is 1. So that's not good. Okay, so that way it doesn't work. Now we have to swap, right? Now remember, when you swap, we might swap both. Have you thought about that? See, that's the complexity. Like you can just not just swap once. You can swap both. All right, I have no idea. Recursion. That's it. Damn, it's easy. Seven. Holy guacamole. Okay, I'm on the left and right, but let's see. I probably have something written down there. I solved it, huh? Is my ability dropping? I think I solved this myself the last time. Current j equals current j minus 1. So with the ith, so I given like 4. If I want to find 3, I need to find 2. And then what? Plus previous find 3. Oh, what does this mean? I don't know what this means. Can't understand my own solution. Let's pick one. Let's pick the most basic one. Oh, that doesn't help. Wait, I have to read this. I know, that's 1. Is this correct? Shift. Okay. If we have this shift idea, we add a number. That's the difference. So previously I was trying to start from n number. And then I would say, okay, if I have n number and I have k minus 1, how does that help n number with k? But no, what this one says is if I have n number with k, what's going to happen if I add an additional number? Okay, so whatever we have previously, and I have an additional number, and I shift to ones, then if I just add it, then it doesn't change, right? Doesn't add anything, so it's the same. But if I shift once, when I add 1, we shift twice. So however many times we shift, that's however many times we can add to the value. Which means if I have all the values previously, like if given n and a k, I have a value, right? Then I add a new value. Then I can shift once. So that's the new value that one can add 1. Shift 2, so that one add 1. Shift 3, that one add 1, right? So basically what we're saying is given and the previous one, like let's call previous as I have I number of values, and we call it dp k. I have whatever, so we have that many for this one, and now pre k, and now I say I have current. I add a new value to it, and then I say I put it here, right? Then I say current k, which is that shall equal to pre-k, right? Plus equal to pre-k. And then current k plus 1 is I shift once, so also plus equal to pre-k. And current k plus 2 all the way to current k plus k minus 1, right? Because I have k pairs. And then we just added 1 pair, right? If I have 3 pairs, and I can add 1, 1, 2, 3. So no, it's the total length. We add a total length of pairs. All is the pre-k. So that means if we go through everything and then if I go through so if I iterate, right? If I iterate through pre-k, I iterate through 1 through k, and for each one, the current, let's say for j in 1 to k, then current j and current j plus 1. So we have to go another one for something like current j plus that plus equal to pre something. That is like 3 levels. Okay, let's keep reading. Okay, then we can start shifting, right? Yes. We can add a new element to this array B at a position P steps from, such that, yes, that's correct. With exactly k inverse pairs. Yes. Yes, that is correct. But then I have to know all of them, right? So now, okay, I think I got the idea, but implementation. I shall go how many times I can shift. Right, how many times I can shift. So I know from 0 to k for the previous one, okay? 0 to k, I know how many ways I can do this. Now a new one comes in, right? I say I want to shift to 0 positions. Then the new one, I want to shift 0 positions. But what if I want to have this one with a smaller value? What do I do? Then I need to go through the previous, right? It goes to the previous at 1, and then for me, I can go through this. Okay, but what we want is k. Okay, we have a target is k, which means for each one, right, I just want to find k. So if the previous is k, then I just copy it. If the previous is k minus 1, then I need to do one shift. So I just record k minus 1, and I record k minus 2, k minus 3 for all of them. And they will add to my current k. Yeah, they will add to my current k value. But that's like all of them will add to the k. But what about k plus 1? So I have to do this, add to this. And if I want to do k plus 1, it has to be k. I move once, k minus 1, I move twice. I don't need k. I don't need k, right? To get k, I need k, k minus 1, k minus 2, all the way to k, let's say n, k minus n, because I can left shift n times. So k minus n. Whichever one's bigger, right? So we add them all together will give me this k. But for the next round, so that's what confuses me, because I only have 2 levels. That's what I don't understand. Oh, I see what this is. So for k, hold on, I think this is an optimization. So for k, we'll add up, so for current k, we'll add up, oh my god, the ability has dropped so much. I can't even think. So just pre-0, right? Add pre-1, add all the way to pre-k. That is current k. And current k minus 1 is equal to pre-0, add all the way, add into pre-k minus 1. Right? Is that right? So that's why we use a cumulative sum. We use a prefix sum for this. Current k minus 2, k minus 3. So what we're saying is current 0 also equal to 1. Then I want to find current 1. So current 1 shall equal to pre-0 plus pre-1. Right? What does this mean? Is currently I have 1 pair. So that's just previous 0 pair, and so previously a 0 pair, or because a 0 pair I shift once, or shift once, or previously How do I know the size? I'll be able to know the size. Because I go all the way to k, right? I go all the way to k. So I can only shift all the way to 0. No, you don't shift all the way to 0, right? Hold on. Oh. I can only shift so much. So if the previous, so I'm looking at k numbers, right? So what I want to add is the previous with k numbers and the previous with k minus 1, so I can shift, right? And I can shift all the way to k minus 2, I can shift twice, and k minus all the way to 0, right? I can go all the way to 0. So hold on, it's not all the way to 0. Let's go all the way to k equals the current one moves to the front. So then by doing that, I get the current value. But remember, we are trying to do this is very, very, very hard for me. I think I did this myself last time, but I'm just not able to do this today. Let's see if we can put this together without referring to the answer. So I'm not able to do this. I think I solved it myself last time, but not today. The key insight is that if we know the total number of ways to form k inverse pairs with n numbers, now we want to add n plus 1. If we add it at the end, then n plus 1 number with k inverse has the same number of ways, right, as n number with k inverse pairs. To put it in dp term, we can say dpi, well, I can go pn plus 1, right, with k is equal to dp n with k, right? Right, if we want to maintain, right, if we want to interestingly, if we shift, right, if we shift n plus 1 one position to the left, then our array has k plus, the array has one more inverse pair. Right. Then O has one more inverse pair. This means by shifting n plus 1 leftwards, one position leftwards, we can achieve k inverse pairs in dp and k minus 1 ways. Pushing this logic further, we say if we shift n plus 1 leftwards 2 positions, alright, then we can achieve k inverse pairs in dp and k minus 2 ways. Thus, we say dp n plus 1 k equals dp n k plus dp n k minus 1 plus plus dp n, what is this one? Well, we can keep going, so it should be k minus the minimum, no, the maximum. No, wait, hold on. The minimum. Wait, what is this? Well, the maximum we can go is the number of ways backwards, right? So it shall be n, but we're gonna have the maximum of this 0, because I can go n step back. Yeah. Another important insight is that the computation of the sum can be facilitated tremendously via prefix sum. Okay, so what do? Well, we produce a pre times k plus 1, that's correct, and then pre 0 always equal 1. Then we say for I in range always have 1, because what we want to find is dpnk, right? And I say current and current 0 equal to 1. Hold on. J is going to be K, right? In range what? I can go shift 0 times or shift 1 time all the way to n times. So it's going to be n plus 1. That's how many times I can shift. Not n plus 1, it's actually I plus 1. I is the number of times I can shift, right? And I'm going to say current J. How many times I can shift? That's not current J though. No, this should be K. No, that's not true. It should be K. This is K. So we start with, oh, we don't start with 0. We start with 1. So what is 1? So that shall equal to, if the pre is a prefix sum. Right, we say make this a prefix sum. So for the prefix sum, I have to add j minus 1 for prefix sum and add everything from pre j minus 1 all the way to this. So it'll be pre j minus something minus well, if we go all the way to 0, that's when, so we can say minus 0 if j is k, if j is smaller than n. If j is smaller than n, which means this one going to be negative, so we'll hit 0. Else, right? Else we say it's going to hit pre I'll probably say smaller equal to, because if they're equal, then we will hit 0 as well. And we shall hit 0, then it's just the whole entire thing. Otherwise, we shall minus j minus n minus 1. Because j minus n is this value. And I want the sum, so it has to be this value. So this is build, right? This is build the prefix sum for the current. current n. Alright, this is iterate through n. This is iterate through different k. And then what? I return current, oh, hold on, pre equals current, and then return current k. Okay, is that right? I think I remember a little bit fives. Well, actually I have a few. Five one is 4. 5 2 is 9. 5 3 is 15. Oh. N and K. Oopsie doozy. Now correct. That's not right. Well, I think what happens is K pairs. That's I. That's throw in. This is I. Okay, still not right. It's getting closer. I move things around. How about 3, 2? Well, I just realized there's no 1, 1. There ain't no 1, 1. So we'll start with 2. There's 1, 0 pair, right? Like 1 pair doesn't have 1 pair. Paired concept starts with 2. If we pass more, these all start on here and fail. Skip 1 because 1 element does not have 1 inverse pair. Doesn't have any inverse pair. And 0 already, so we'll go with 1. There's 1, I'll say previous 1 minus if j is equal to this I is the maximum number I can shift. And every time I shift, I can add that. So if I can shift that many times, basically I shift all the way to the front. And I should add all of them. Else, if I can only shift j the number of times I can shift, because I shift 1 time I produce 1, so I shift j times. That should be if I shift one time, right, then I shall do should be I minus j, right? Okay, shift once, and that, I shift twice, and that, and shift 3 times, add that. I can keep shifting, right? I shall be able to keep shifting until I reach, remember, J is the number of shifts I can do, right? As the number of shifts I can do. Oh, hey, hold on. What? No. J is K. J is K. J is the number of pairs. So this number of pairs is the previous number of pairs. It's to just K minus 1 minus 2 minus 2 all the way to I cannot shift. Maximum times I can shift, right? Maximum times I can shift. I don't know. Maybe this is 1 because I want this to be a prefix sum. No, that's not right. What was it? So I equals 2. I equals 2. Pre is this, okay? And then you guys should put it here. So with 2, 0 is a 1, 2, 1, 2, 0, 2, 1, and 2, 2. 2, 2 is not 0, right? 2, 2 is not 1. It cannot have 2 pairs. We cannot have 2 pairs. So the maximum number of pairs should be that's the maximum number of pairs. So maybe I should say if j is larger than I minus 1 times I divided by 2, then we're going to break. Because that's the maximum number of pairs I can have. Almost. Yeah, it's a 1. 3, 3. y is 1. So it's 3 values on 3 pairs. If it's larger than, if it's equal to, that's only 1. Wait, shouldn't this be current k minus current k minus 1? Because this is a prefix sum. It doesn't work. I have 0 inverse pair. on break. Because it's going to be 1, it'll be 0. Alright, I want to end it. I'm falling asleep.